let me tell you a little, let me use my camera as an example. I love this camera. I love this camera. It took that picture and made me a better photographer than I am. And this is it. It's a Canon 5D. It has 17 elements in this lens. I've got 10 elements in the wide-angle lens. And let's take a look. I cheated a little bit. I know how much it weighs. I just have to do this to show you. With my wide-angle lens and my zoom that goes from 100 to 400, we're looking at 6 pounds. 6 pounds of camera. I mean, I do love this camera, but boy, am I lugging around a lot of glass when I carry it. And it's kind of, well, you get what I mean. And the other thing, well, there are a couple of other things about that digital flat sensors really restrict your ability. When I was taking that whale shot, you know, when I do this, I can feel air squeezing out. And when I'm on the bow of a boat and there's salt waves splashing across the bow, and I'm doing this, I know it's sucking in air. That makes me a little nervous to be sucking in air when it's salt air. Okay, I want to show you something else about single lens reflex cameras, and actually not show you, I want you to hear this. Hear that clunk? This isn't a digital camera. This is a mechanical camera. The mirror has to move, slap up and down. That's a lot of moving stuff as well as the moving elements in the lens. This is a mechanical camera. Digital cameras will be coming. Okay, I want to say one more thing about my Canon 5D, and I love that camera. When I was taking that whale shot, do you think I changed lenses? No, there was a whole pod of whales that I could have switched to my wide-angle lens, but I'm horrified by the thought of changing lenses out in the middle of salt water. This is the problem with SLRs, and it's a big problem with digital SLRs. You get a dust speck on that sensor, and you are going to get that dust speck on every single picture. With roll film cameras, at least, it got rolled away. But not so with digital cameras. So some of the manufacturers today have put an adhesive strip inside and they have the sensor vibrate to get rid of dust. Probably a good idea if you're holding the camera in the right direction when it vibrates so that it falls into the adhesive strip. But now you've got a service call every few years to replace the adhesive in the strip. And there's no reason to have interchangeable lenses. We can do it all with curved sensors. Now, I want to talk just a little bit about lens choices. In my Canon line, which is kind of like Nikon, both Canon and Nikon have terrific choice of lenses. Inarguably, these two are the best on the market, but they are slow by historic standards. Of the 57 Canon lenses, 54 have f2.8 to f4 speeds, and that's the fastest speed. That is very slow. It gives you huge depth of field, so you're going to get all the clutter in the background and foreground that you don't want. But let's take a look as an example at the Canon lenses that are fast. Now, these are not zooms, so they can be faster. You've got an f1.8, which has 6 elements, an f1.4 with 7 elements, and an f1.2 with 8 elements. When I bought my first Pentax 40 years ago, these lenses were available then. An f1.2 is unheard of. Going from an f1.8 to an f1.4 is a small gain in speed. And by that, to you potential investors, that means the amount of light getting through the lens. You add 1 element to get a small gain in speed. Going from an f1.4 to an f1.2 is a teeny tiny gain in speed. And look, you add another element yet. You're hitting a wall here. It's a flat wall. How far can you go to gain speed? Not much further when you have a flat sensor. Now, let's talk for a minute, just a minute, about another phenomena that is very fundamental to the entire industry, and that's the gain in pixels. We're just 10 years into this race. Kodak came out, I think, about 10 years ago, and they had about 3 megapixels, is my memory, in their DC-5. That would have been in 1999. Then in 2003, Canon came out with a EOS line, and those were 6 megapixels, as I recall. I know that in 2006, my Canon came out with a whopping 12.8 megapixels, and in 2009 it's already been obsoleted, not only by another Canon model, the Mark II, but surpassed by Nikon with their D3X, which has 24 million pixels, almost as many as we have rods and cones in our eye. So we get 25 megapixels. Do we really need optical zoom anymore? I don't think so. And we can go much further than that with curved sensors. Optical zoom will be dead in 5 years. I know this is controversial, but we will re-examine it in a minute. Let's take a look at how you make a curved sensor. Now, this is my art. This isn't quite the way you would do it, but most people don't understand that silicon can bend. You roll it thin enough, it is bendable. So you just trim out a little trumpet shapes like this, and you can take that wafer or that sensor and you end up with a shape like this, and then what you do with it is you fold it into a curved shape. Now, if you look at our patents, and happy to give you our filings, you'll notice that we did slightly different way in the description on those. Instead of having them butt against each other, which might be kind of hard, we had them kind of overlap like a pinwheel, which is probably the easier method. Now, is this the method that we think we would propose? We think not. We think there are easier ways, and let me show you what that might be. Here's a simple way that this is just a paper cutout that shows how you can make a curved surface out of a lot of flat surfaces. And the more flat surfaces you have, obviously, the closer to a perfect curve you get. But just for a moment, let's consider what's really happening here. You have a flat surface, and as the light bends, as the rays get a little bit off axis, you still have pretty much the same angle and not much distance added to the light source and the film sensor or film. As you get out here near the edge, it gets big. This is not a linear, this is an exponential, and just remember your trigonometry, and that'll make some sense. So doing something flat like this, maybe it would have more than that, maybe more facets than this. That becomes a mathematical and production question that we have not delved into yet, but we will.